Take every weight in a neural network and treat it as a coordinate. One weight, one axis. Then add one final axis. How wrong the network is. Its loss. What you get is a landscape. Millions of dimensions of terrain with valleys where the network is right and peaks where it is wrong. Training a network is nothing more than hiking downhill through this landscape, blindfolded. C is the topography of error. The height of the terrain comes from the objective function, squared error, cross entropy, negative log likelihood. Different ways of scoring a prediction against the truth. Pick one and every possible setting of the weights gets a number. Low is good. The whole game is find the weights at the bottom of a valley. You can't see the whole landscape. It has millions of dimensions, and you only ever stand at one point. But you can feel the slope under your feet. That's the gradient, the direction of steepest descent, computed by backpropagation, one chain rule step at a time. And if the gradient points uphill, the negative gradient points exactly where we want to go, down. The whole algorithm fits in one line. New weights equal old weights minus the learning rate times the gradient. Feel the slope. Take a step downhill. Repeat. That's gradient descent. The engine inside almost everything that learns. The learning rate is the size of your stride, and it decides everything. Too small, and you shuffle downhill for a lifetime and never arrive. Too large, and you leap clean across the valley, ricochet, off the walls, and climb, diverging instead of descending. The sweet spot drops you into the basin in a handful of confident steps. One more problem. Measuring the true slope means checking every training example in the dataset for every single step. Stochastic gradient descent sheets. It feels the slope on a small random batch instead. Each reading is noisy, and the path staggers like a drunk hiker. But the steps are cheap. You take thousands of them. The noise even helps you rattle out of bad terrain. Modern optimizers give the hiker physics. Momentum turns the walker into a heavy ball. Velocity builds downhill, small bumps stop nattering, and narrow ravines stop causing zigzags. Adaptive methods like Sprop and Atom go further. Every dimension gets its own stride length. Shorter steps where the terrain is steep, longer steps where it's flat. Same idea, better legs. The landscape is riddled with local dips and saddle points, and in millions of dimensions, we will never see it. But we don't need to. Feel the slope. Step downhill. Do it a few million times. And somewhere down in a valley, a network wakes up knowing how to read or see or speak. That's the topography of error.